Yes, so it has started. Okay, so let us move on towards our example number two, which is says basically this is lecture number 9, physics optional, and in this lecture number 9 we are going to see another example in which the potential function we have to find out. Okay, and potential function we have to find out with the help of this. Okay, with the help of this we have to find out the potential function. So what is given to us? A time dependent. Okay, a time dependent wave function has been given to us. This is that time dependent wave function. Okay, so time dependent wave function of a particle of mass m. Okay, particle of mass m moving in one dimension. One dimension means only x term will be there, r term will not be there in it. Okay, r term will not be there in it, only x term will be there in it. That's what is meant by one dimensional. I have already discussed this in the previous 8 lectures. You can go and watch over there. Okay, so time dependent wave function of a particle of mass m moving in one dimension under the influence of a potential v of x is given by this, where alpha beta and gamma are real numbers. Okay, alpha beta gamma are real numbers. Alpha beta gamma are real numbers. That means if I take the square of this, it is also going to yield me a real number. Okay, real and positive number. Okay, that's what is meant by alpha beta gamma are real number. Okay, because only imaginary numbers like iota have square equal to negative number. Okay, only imaginary numbers have square equal to negative number. Okay, all the real numbers have square positive only. Only imaginary numbers have square negative. Okay, so alpha beta gamma real number implies that alpha square beta square gamma square all these things are real, and they yield a positive number. That's what is meant by this statement. Alpha beta gamma are real numbers. Okay, so we have to find basically potential function v of x for x greater than 0. Okay, for x greater than 0 we have to find the potential function. Okay, so we will basically use the formula. I had already told you in the previous classes that h psi equal to e psi is our formula. H psi equal to h psi of x equal to e psi of x is our formula. This formula holds when time independent function is given to us. Okay, this formula holds when time independent function is given to us. Okay, but when time dependent function is given, when time dependent function is given we have to use this formula. Okay, in case of time dependent one. Okay, in case of time dependent we have to use this formula. Now while using this formula you have clearly seen that in the time independent formula e is not substituted like this. Okay, e is not substituted in this form in time independent equation. In the time independent equation e is not substituted like this. Okay, but in time dependent equation e is substituted like this. Okay, so h psi equal to I h cut del y del t psi x comma t. Now this is basically your capital psi, right? I had told you in the previous classes that this corresponds to capital psi. Okay, and this corresponds to small psi, right? This corresponds to small psi. Now capital psi, as you know this very well, that capital psi represents time dependent function. Time dependent wave function is represented by capital psi, and time independent wave function is represented by small psi. Okay, I had already told you all this in the previous classes. Okay, so basically we are representing it by capital psi because it is a function of x and t both. Okay, so as it is a function of x and t both, so it is being represented by capital psi. Now I will put the value of h over here. The h Hamiltonian operator. Hamiltonian operator is defined like this, that it is minus h cut square divided by 2m del 2. This is basically operator. In the upcoming classes these are going to be discussed in detail. Okay, we are going to discuss these in detail in the upcoming classes, but right now I am discussing this with respect to solving the problem. Okay, for solving the problem purpose we are discussing this in the superficial manner right now. Okay, So Hamiltonian, your Hamiltonian, okay, this is your Hamiltonian, and it is defined like this. It is Hamiltonian operator. Okay, so I have put the value over here, and psi x comma t value I will put from here. Okay, as it is given in the question that you have to find v of x for x greater than 0. It is clearly given in the problem that you have to find v of x for x greater than 0. Okay, you have to find v of x for x greater than 0. What does this mean? This clearly means that for x is smaller than 0, we have to ignore the value. Okay, psi of x comma t, capital psi x comma t value for x is smaller than 0, it is 0. Okay, for x is smaller than 0, capital psi of x comma t value is 0. So we have to clearly ignore this downward statement. Okay, this statement given below one, the below one we have to ignore, because it is clearly given that v of x we have to find for x greater than 0, and x greater than 0 corresponds to this wave function. Okay, so the 0 value you can ignore clearly. It is just given for time pass purpose. Okay, time pass purpose means in order to confuse you it is given. Okay, but you should not be confused. It is a very much straightforward problem. So psi of x comma t value you will put this one, x greater than 0 value you will put. Okay, x greater than 0 value you will put over here. Okay, x greater than 0 value you will put over here. Why? Because x is smaller than 0 is equal to 0, and you have to find v of x for x greater than 0 only. Okay, for x is smaller than 0, you need not find v of x. So as you need not find v of x for x is smaller than 0, you can clearly ignore this downward value. Okay, so that's why now psi of x comma t has been put over here. It is put over here. It has been put over here, and over here I h cut del by del t, again this value has been put. Okay, so those two values have been put. Now clearly you can see one thing over here, that your function, what is this function basically? Okay, it is alpha x e to the power minus beta x e to the power I gamma t by h cut, right? It is given like this, right? So clearly you can see this thing over here, that when I take del by del x of this. Okay, when I take del by del x of this function, which is given like this, alpha x e to the power minus beta x e to the power I gamma t by h cut. Okay, it is given like this, right? So clearly you can see one thing over here, that it is del by del x, right? So t it is this one is purely a function of t only, right? this one this one is purely a function of t, right? So as it is purely a function of t, it can be put out of the differential sign, because it is partial differentiation, not full differentiation. It is partial differentiation, so function of time can be put out of this differential. Okay, and alpha value can also be put out of this differential. This is very clear from here. Okay, so only thing which will remain inside the differential, is x e to the power minus beta x. This term will remain inside the differential, only this term will remain. Okay, now we have to take the differentiation two times, so I will just do this thing. Okay, so we have to find this value in short. Okay, so over here lot of crowd will be there. Okay, if I keep writing this, if I suppose keep writing all the steps over here. Okay, if I suppose put this value inside the bracket, and then I keep on writing this long expression. Okay, this multiplied by this, and then this multiplied by this, I keep on writing the long expression over here, then the problem will be that it will be overcrowded, and if it will be overcrowded, the chances of error will increase tremendously. Okay, chances of error will increase tremendously. So in order to avoid that, we will simply find out the value of this. We will find out this double differentiation, double partial differentiation with respect to x e to the power minus beta x. This we will find separately. Okay, this we will find separately. Okay, this we will find separately, and then after that we will put its value in this equation number 1. Okay, we will find this separately and then put this value in the equation number 1 later on. Okay, so we need to find del by del x, x e to the power minus beta x. Now this is quite evident. The UV formula we will apply. We'll apply UV formula and find it separately, okay, in order to avoid crowd. So del y del x of x e to the power minus beta x, right? So clearly you are yeah, first of all I will take differentiation of this, keeping this as constant, okay. So first of all I will differentiate this keeping this as constant, and then I will differentiate this keeping this as a constant, okay. So that is basically UV formula. What is your UV formula? Your UV formula says that you have to first of all take the, okay, take the differentiation of u, and then u del v by del x after that, okay. So clearly this thing is visible that it will be uv formula. So after using the uv formula you get this thing, okay. Now so del x by del x has turned out to be, del x by del x has turned out to be 1. So over here in the multiplication it is 1, okay. And del by del x of this thing will come over here, and x will remain, x will remain over here, okay. So e to the power minus beta x, e to the power minus beta x, and again after I take the differentiation of this, what will happen? If I take the differentiation of that thing, okay, then clearly it is visible that e to the power minus beta x will remain. Chain rule I will apply, and after applying the chain rule, okay, after applying the chain rule I will get something like this. Then after that e to the power minus beta x will remain, and the minus beta will come, okay, in the multiplication, because del by del x and this x, okay, this x, this x and del x by del x, okay, will come out to be equal to 1, okay. So basically that's the thing which is over here, okay. And x is in multiplication, okay. So minus beta x will come in the forward direction, okay. So minus beta x has come in the forward direction, and e to the power minus beta x has remained, okay. So this is the thing. Now I got this single differentiation. I had to find the double differentiation. So in order to find the double differentiation, I will again differentiate it partially with respect to x. And when I again differentiate it partially with respect to x, it is very clear that it is a linear operator, right? Differentiation is a linear operator. As it is a linear operator, so it will first of all apply on this, and then it will apply on this, okay. Because you know this very well that del of del x of u plus v, what does this come out to be? This comes out to be del u by del x plus del v by del x. It is equivalent to this, okay. So it is a linear operator. Such operators are called linear operators. So differentiation is a linear operator. So clearly you can this differentiation symbol can will first of all go with this, and then it will go with this, okay. So it has gone with all the two terms, okay. So again the differentiation of this I need not tell you, it is very easy, okay. This thing then I will get very easy na, del by del x. Now, right now I had solved it some moments ago, okay. So when I take the del by del x, e to the power minus beta x will remain, and del by del x of minus beta x will remain, okay. So e to the power minus beta x is there, and minus beta will come out, okay. So minus beta multiplied by e to the power minus beta x will remain, okay. So this is the thing, okay. And beta will come out of this differentiation symbol. So beta has come out clearly, and del by del x of x e to the power minus beta x, okay. So this del by del x of x e to the power minus beta x, this term, okay, this term over here, this has been already found out. This term has been already found out over here. This term has already been found out over here. So I will put this value over here, okay. Over here I will put that value. So after I put that value over here, clearly this term will come over here, okay. So then after that del 2 by del x square of this thing has come out to be equal to this thing, okay. So this is clearly visible, okay. So now I will put the double differentiation value in equation number 1. Okay, so equation number 1, what does it yield here? Yield us. Okay, equation number 1, this is equation number 1. This clearly yields us this function. Okay, this function will go here also, and it will be multiplied by v of x also. Okay, so I will basically expand the bracket. So after expanding the bracket, I see that e to the power all those terms. Okay, this term in the LHS and this term in the RHS will cancel out. Okay, those two terms will be cancelled out. So clearly you can watch the steps also. Okay, there is nothing big in it. Okay, so those two things will be cancelled out. Now this is very quite evident that I will take del by del t of this thing. Now when I take del by del t of this thing, it is very much visible that this term is will be treated as constant, as they are function of x only, and we are taking partial differentiation with respect to t. So as we are taking partial differentiation with respect to t, so the x terms will be treated as constants. So these x terms will come out of the differentiation symbol. So x terms, let them come out of the differentiation symbol, and after they come out of the differentiation symbol, they look something like this. And all the other terms remain as it is. Okay, only this term has been differentiated. So when that term is differentiated, del by del t of e to the power I gamma t over h cut, right? This is the expression, right? So I will basically exponential function will remain as it is. Now the exponential function has remained as it is. Okay, and again del by del t multiplied by this is being multiplied by del by del t, and I gamma t over h cut, right? So basically e to the power I gamma t over h cut, okay, multiplied by uh, I gamma, okay, I gamma over h cut. Okay, so basically that's the thing which has been written over here. Okay, how did this come? I told you. Okay, so basically you got that thing, and after the further simplification, this term is going to cancel out from the LHS and RHS. Which term is going to cancel out? Alpha e to the power minus beta x, alpha e to the power minus beta x. Okay, this term is cancelling. This term is cancelling. Okay, this term this term is cancelling. Okay, so you are basically left with this, and after you are left with this, you can clearly find out v of x. So you found out v of x. So after finding out v of x, you got this expression. Now after looking at the after close inspection of this expression, after close inspection of this expression, we can clearly see one thing, that it is of the form y equal to mx plus c. Okay, this expression is of the form y equal to mx plus c. Okay, why is it of the form y equal to mx plus c? Because y is equal to your v of x over here. Okay, and m is equal to m is equal to your this term is equal to m. Okay, x is as it is. Okay, and this is basically your c. So it is of the form y equal to mx plus c. And in the previous class I had clearly told you that in the university exam, finding up to here that v of x equal to something, finding up to here is enough for the university exam. But as far as the IAS physics optional exam is concerned, finding up to here is not at all sufficient. You have to go further. You have to discuss the result. Okay, you have to discuss how is it how its graph is going to be. Okay, you have to discuss the expression that it is linear expression, so it will yield such and such graph. What will be its y-intercept? What will be its minimum value? What will be its maximum value? You have to basically interpret it. Okay, in order to grab more marks. Okay, because if you solve up to here only, and if the suppose question is of 10 marks, then the examiner will award you only 3 marks in the physics optional IS exam if you solve up to here only, like the university exam. But if you describe this by drawing graph and etc., it is quite possible that he might give you 6 out of 10. Okay, So in order to grab marks, you are going to do this. So I have written v of x equal to k1 plus k2 x, okay, which is of the form y equal to mx plus c, very similar to that, okay. So clearly one thing can be seen over here, that your k1 will come out to be equal to this and your k2 will come out to be equal to this after comparison, right? After you compare these two expressions, your k2 is equal to this thing, okay, and your k1 is equal to this thing, okay. So k1 and k2 values are over here, okay. Now v of x and this is basically x axis, okay. So in the place of y axis we have v of x, and in the place of x axis we have x, okay. So after that we will just simply you find the y intercept using the y equal to mx plus c formula. We will see the y-intercept. So in order to get the y-intercept, we will put x equal to 0. Okay, in order to get the y-intercept this much. Okay, in order to get the y-intercept, we need to put x equal to 0. So as soon as I put x equal to 0 over here, as soon as I put x equal to 0 over here, I will get the y-intercept. So what will it be equal to? Your y-intercept. Okay, your y-intercept will come out to be minus h cut square over m beta, okay. This is your y-intercept, okay. So and similarly, in order to find the x-intercept, okay, the line is looking like this, right? So in order to find the x-intercept, yes, and now it is quite evident from this fact that y-intercept is clearly negative, okay. Y-intercept is clearly negative. Because this has been given in the question, okay, that your beta is a real number, okay. What is given in the question, okay. So whatever may be, but it is we are taking a generalized case, okay. Don't go into the such things that what if beta is negative, then this negative and negative will yield positive. No, don't think like that, okay. You have to draw a general graph, okay. So no matter whether beta is positive or negative, you have to by default consider beta is negative only, sorry, positive only, and consider this value as negative. So minus h cut square beta by m, this is clearly negative after putting x equal to 0. X equal to 0 is at this point. So at x equal to 0, we are getting y value this much, okay. So y value I got this much. So this intercept is clearly equal to minus h cut square beta divided by m, okay. This is the y-intercept. Now after putting y equal to 0, y equal to 0 is at this point, right? This point corresponds to y equal to 0. This point corresponds to x equal to 0. Now this point corresponds to y equal to 0. So after I put y equal to 0, means this term equal to 0, I will get certain value of x, and that value of x is equal to minus k1 over k2, okay. Minus k1 over k2 means this divided by this, okay. So this is clearly a positive number, okay. So means you can consider it to be positive number by assuming beta and gamma to be positive, okay. If you assume beta and gamma to be positive, it is going to yield you a positive number. You are drawing basically general graph, okay. In fact, the graph may look like this also, the graph may look like this also, but you are drawing a generalized case, okay. So in the generalized case, we are taking this, okay. So your the x intercept clearly came out to be equal to this, okay. So as your x intercept came out to be equal to this, it is clearly from here to here, right? And y intercept is from here to here, okay. So basically comparing the expression v of x with the equation of straight line, I have written those things which I explained, right now have been written over here, okay. So slope m equal to k2, and this is the thing, y intercept equal to this much, okay. Negative potential exists for, now this is very interesting fact, okay. Negative potential, you can see this clearly, that at this point the potential is 0, okay, because v of x corresponds to 0 at this point, okay. Above this point the potential is positive, and below this point the potential is negative. Now you only tell me, if the potential is negative below this point, then we can clearly say that up to the distance x equal to, it is one dimensional, right? It is given that it is one dimensional. So in the one dimensional potential, we can clearly see that up to the distance x equal to minus k1 by k2, the potential is negative. That means that this area has attractive force in it. Okay, because negative potential implies attractive force. Okay, so this area will have attractive force in it. This area, all this area up to infinity will have repulsive force in it. Okay, and the minimum value of v of x, what is it equal to? Your minimum value of v of x, it is clearly given in the question that x equal to x is greater than 0. Okay, you have to find for x greater than 0. Okay, and in the question it is given that we have ignored this. Okay, and in the question also we are it is said that find out for x greater than 0. So clearly for x is smaller than 0 we cannot draw the graph. For x is smaller than 0 means in this area we cannot draw the graph. So in this area, as we cannot draw the graph, it is quite evident from this that eventually the minimum value of v of x is going to be minus k1. Okay, minus k1 means k1. Okay, which is equal to this. Okay, this is the minimum value of potential. Then the potential keeps rising. Okay, then this negative potential reduces. Okay, negative potential reduces means attraction decreases. Over here the particle experiences no force, and after that the particle begins to experience repulsive force. Okay, so for exist negative potential exists for this, the particle experiences attractive force in this region. Okay, the particle experiences attractive force in this region. At x equal to minus k1 by k2, the potential is 0. Clearly I have shown in the graph, which the particle experiences no force at this distance. Only at the distance this, the particle will experience no force as the v of x value is 0. Okay, so as the potential function corresponds to 0, the particle experiences no force at that distance. Okay, below this distance, below this distance means from 0 to this, from 0 to this, the particle experiences attractive force because v of x is smaller than 0. So particle will experience attractive force. And after this, suppose x greater than minus k1 by k2. Okay, which is given over here, v of x is clearly positive. So as v of x is positive, clearly the particle experiences repulsive force in this region. Okay, so and for v x equal to 0, v of 0 equal to this, the attraction experienced by the particle is maximum in this case. Okay, some students ask over here that you are drawing this graph, you are basically drawing this graph considering beta to be positive, beta and gamma to be positive. Okay, you are considering beta and gamma to be positive, then you are drawing this graph. Okay, but some student ask, what if it is only given in the question that alpha beta gamma are real, it is not given that alpha beta gamma are greater than 0. It is not given in the question. Only thing given in the question is alpha beta gamma are real. It is given in the question like that. Okay, so only thing which is given in the question is alpha beta gamma are real. Then how come you are considering that alpha beta gamma are positive? It is not given in the question that they are positive. Then why are you considering like that? They say that k1 equal to y-intercept, which is equal to minus h cut beta over m. They ask me that what if beta is equal to negative, then this negative and this negative will become positive. Okay, and mass is positive, so this graph will come like this. Yes, you are saying truth, no doubt in it, but I am taking a generalized case. Okay, I am taking a generalized case. If you want to overcomplicate your problem, you can go for it. You can go for beta negative if you want to overcomplicate the problem. But that is not the requirement, because the main question has already been solved. Okay, the main question has already been solved when you found out the v of x value. Problem is up to here only. Okay, why are we doing this exercise? Why are we doing this extra exercise? In order to grab more marks in the physics optional exam. Okay, is exam. So that's why we are doing it. So why will we consider beta positive and beta negative two cases and unnecessarily overcomplicate the problem and make the problem very very lengthy? Okay, in that case you can't complete the question paper at all. Okay, so instead of doing that, we are not, that's why we are not doing that. Okay, we are considering a generalized case, that suppose normal वाला case है, मतलब general वाला कि बीटा ग्रेटर देन 0 ही है भाई. Okay, so we are considering like that. So this is the thing. So this is the problem which had been asked in your one of your previous years. Okay, now I will end the class over here, and I would like to tell you something that some of the students are asking the doubt in the comment section. Okay, so whosoever is asking the doubt in the comment section, remember one thing, beta, that I cannot reply to the comments because there are a lot of comments. Okay, every day I get about 20-25 comments every day I am getting. Okay, so replying to each and every comment is not possible for me, and your doubt is just hidden in those 25 comments. Okay, so it is very hectic for me. So in order to avoid that, you can just WhatsApp. Okay, you can just WhatsApp on 724918703. Okay, you can just WhatsApp your doubts over here. Okay, so 724918703. This is the WhatsApp number. You can post your doubts on this WhatsApp number. And let me tell you one thing, that uh, इनको डेंगू हो गया है. Okay, he has got dengue. Okay, so his twin brother, that is me. Okay, his twin brother, his twin, that is me, will take your doubts also, and will handle this also, because he is completely at bed. Okay, he is completely at bed. Okay, even right now the video is off. The video is off because he is sleeping behind me. Okay, he is sleeping behind me, that's why the video is off. Okay, so that's why we have put the video off, because it doesn't look good that someone is sleeping behind and you are recording the video. Okay, so thank you very much. Jai Hind, Jai Bharat.